Hello, everyone. Please type in your emails in the chat so I could take attendance. Can you guys see my screen? Okay. Jeopardy style, like usual, just shout out the answer if you know it or type it in the chat. Let's begin. This first section is about proteins. How are proteins created?
Is it branched chain of amino acids?
Yes. And it starts from having all of those amino acids floating around. But in order for our body to know how to build the specific function of what we need, our DNA tells the mRNA, and then the mRNA tells the ribosomes how to build it in the rough ER. And then the tRNA, and they create the polypeptide chains. And if they're exported, they're packaged in the Golgi apparatus. And yeah. Do you guys remember at what stage of the amino acid chains, like what's it called when the protein is functional?
Is it during like the quaternary structure?
Yep. So in the primary and secondary and the tertiary, they're not functional. And when we cook protein down, like eggs and like chicken or something like that, we try to make them not functional because you don't want to consume and like take the function of what you're consuming. Even our body will break it down. Why does our bodies need protein? What do proteins do in our bodies?
Um, they're a structure builder.
Yep. They build structure. There's like a lot of things that protein do, but Dr. Rose just says they just do the work of cells. And here are specifically more information about what specifically of the work of cells they do. And I think like before taking this class, I was all like, oh yeah, they're just for muscle, but they do muscle and way more than that, as you can see. Okay, what causes proteins to denature? Why is denaturing important? What is denaturing? High temperatures cause proteins to denature. That's true. High temperatures, as well as acidic things and enzymes and alkaline solutions and agitation. So, like sometimes in some cuisine, they would cook meat in just lemon or vinegar. you don't use heat or anything, and it's totally fine and safe for consumption. So that's pretty cool and tasty. And denaturing, it reduces the biological activity, like we talked about earlier, about how you don't want that egg to like have the function of an egg and become a chicken, turn you into a chicken, you know? I don't think that's physically possible, but that's like the whole point of what denaturing does. You don't want the proteins to work. What are food protein allergens?
Is it like the inability to break down certain sugars?
Not sugar. Sugars is a carbohydrate, but food protein allergies is specific proteins that our immune system mistakes for harmful invaders and overreacts, and introducing these early in life could prevent allergies. And there's like a bunch of common ones like nuts, dairy, and like eggs, sesame, fish, seafood, and all that. Specifically, like these foods have an antibody or antigen on top of them, and when our body like looks at them, they're just like, oh no, really bad guy, and overreacts and starts using all of our like white blood cells and causes inflammation. And then if you ever took microbiology, it's called a cytokine storm. So these are really could be prevented if you introduce it to like an infant at 6 months. Okay, how does protein move substances across the plasma membrane?
Would it be through active transport?
Yes, through active transport or passive transport, or even through pumps like sodium potassium pumps. They move substances up concentration gradients and even through like osmosis. And this helps the hydrophilic substances cross plasma membranes. They are carrier proteins. So they are specifically like standing on top of cell membranes. And if a molecule comes that matches it, they could like function a certain way, like sodium or potassium needs to fill like the slots of the carrier proteins. So yeah, like active transport would need specific ions for it. Okay, this next section is on lipids. What are cis and trans fat?
Um, Trans fats are the man-made ones, and then our cis fats, just the more natural ones.
Yes, they're both byproducts of hydrogenation. They both have double bonds that have been straightened out. Cis is when the hydrogens face each other, while trans is when they're the opposite. And partial hydration of unsaturated fats result in some formation of trans fatty acids. So this is looking like if you go to a grocery store and you see a vegetable spread that is like sort of like butter, but it's made completely from vegetables, and that usually has some proportion of trans fatty acids or cis, well, I guess it's cis fatty acids because trans fatty acids have been banned in the US because our bodies cannot process it. But it's cool that it turns room temperature, like plant-based fats that are usually liquid at room temperature, turn them into like a semi-solid. Okay, what are signs of fatty acid deficiencies? dry skin and hair loss. That's true. There's a lot of symptoms that are related to other nutritional deficiencies. So sometimes you can't tell if it's specifically fatty acid deficiency, but because in epithelial tissues, like the ones on our skin, they're rapidly turning over, the skin becomes flaky and itchy because it's not having enough fatty acids. As you know, cells are created with a phospholipid layer. So wound healing may be slow. You could experience diarrhea, hair may fall out or lose its pigment, and it's more vulnerable, like the people who suffer from this are more vulnerable to infections. Growth may be restricted among children. But this isn't a problem in the US because one of the most like gravitated towards nutrition wise that children have is like, lipids. Like kids want to eat like greasy food all the time. So this isn't like a big concern in the US. What are chylomicrons and why are they important? These might be one of my favorite molecules to look at. They look so crazy. Yep, they're lipoproteins. There are triglycerides, other dietary lipids, cholesterols, fat-soluble vitamins packaged into lipoproteins called chylomicrons. And this is a very important structure to know in nutrition because we spent so much energy in our body to break it down. As you remember that we talked about before, the lipids are really like long chain, have a lot of bonds. So it takes a lot of energy to break it down, which is great because then we'll get a lot of energy from lipids. But we don't want them floating around in our body because water and lipids don't mix very well, like from a salad dressing. So they form into these chylomicrons. I wish I had a picture to show you, but I bet you guys know already how that looks like. Very funny looking thing. Okay, what are the differences between low density lipoprotein and high density lipoprotein?
Isn't one good cholesterol and one's bad cholesterol, quote
Which one's
unquote?
which? Yeah, quote unquote.
Low density is good and high density is bad now.
The low density lipoprotein, it carries cholesterol made by the liver and from other sources to the cells. So oxidized low density lipoprotein particles are taken up by scavenger white blood cells to form plaque in blood vessels, which increases the risk of cardiovascular disease. So it's the other way around. This one is the harmful one because if we consume a lot of cholesterol and our liver is also producing cholesterol, this is bringing it to the cells, which could create plaque in blood vessels and lead to cardiovascular disease. On the other hand, high density lipoprotein is the good one. I always think of it as like harmful starts with the age, so it is high density because it starts with the age, even though usually they should correspond, but it makes sense in my head. It removes cholesterol from cells. It tells the liver to stop producing cholesterol and excretes cholesterol from the body, which reduces risk of cardiovascular disease. And if you guys ever get blood work done, they could test for these things too, which is pretty cool. But it only tests for like the moment of that time because as you know, when you consume a lot of different things, it could fluctuate. But having a high HDL is a really good thing than a low HDL. And having a high LDL isn't a very is a very harmful thing because it could cause it means you have an increased risk of cardiovascular disease. What are differences between omega-3 and omega-6?
Isn't omega-3 better for you than omega-6? I'm not sure if omega-6 is necessarily good for you or not, but I know omega-3 is.
Why is it good for us?
Um, I don't know, it's found in salmon. Um, it helps with energy storage.
Okay, I also wrote a lot of information here. You're right, omega-3 is found in fatty fish. And these two, in my head, I see them as like partners, not like good or bad, but also having too much of either is very harmful for you. Omega-3, it is specifically related to decreasing blood clotting. And so when you have like high blood pressure or cardiovascular disease, eating omega-3 is helpful for decreasing blood clotting, and it increases vasodilation, which means you have better circulation, opening of veins and arteries. There's less traffic inside your blood, less blood pressure, less tension. So they all sound like good things, right? But if you only consume omega-3s, you're just going to keep bleeding out. Like if you get a cut or like a bad wound, like your blood won't clot, and that could be problematic as well. And the omega-6 is the opposite of that. Like they're besties. Omega-6 increases inflammation and blood clotting. And it is could also be harmful if you consume too much because you don't want blood clots to just form anywhere, you know? So eating them in regulation is important, but eating too much, of course, is problematic. Okay, next section, hormones, absorption, and digestion. What is I was afraid to say this word, cholecytokinin, CCK.
Um, it's a hormones. I don't know what structure it's secreted by, but it has something to do with after we eat, I believe with protein and fats. It signals our hunger.
Yes, it does signal our hunger for satiety, yeah. CCK, it causes the pancreas to release pancreatic enzymes like trypsin in the duodenum to break down proteins into smaller peptides and amino acids for absorption. It also causes the gallbladder to release bile into the duodenum to break down fats. And it causes lipids to be secreted. It suppresses your appetite and it works with leptin to regulate hunger. It stimulates peristalsis, which is the movement of chyme through the GI tract. So it tells our body that we are full instead of like when we're eating a lot of food. And it's creating a lot of enzyme processes so we could break down the food we already have. So it's a very helpful hormone. How are lipids digested and absorbed? We sort of talked about this earlier, but this is just like tracking the whole process from when you consume it all the way to when it gets stored, which is a very different process than the other macronutrients. Okay, we can start backwards because I feel like you all know. How are lipids stored?
Is it mainly subcutaneously?
Subcutaneous in what kind of tissue?
Epithelia? I don't know how to say it.
In specifically adipose tissue. So that's like where all of the lipids conglomerate subcutaneously, yeah. And then
And visceral now,
yeah,
which is closer to the organs, right?
yeah.
Okay.
So that's where they're stored. But how do they get to the visceral or the subcutaneous storages?
Phospholipid membrane.
Yeah, they're also in the phospholipid membrane, but they take a specific pathway to get to those places that isn't where proteins and carbs go. Do you guys remember? Okay, so going backwards, they enter to the adipose tissues in those places through the bloodstream from the lymphatic system. So all your lymph nodes, your lymph, all of that. And then before that, they enter through the lacteals, through the small intestines as chylomicrons. And lipids are primarily digested in our small intestines. Bile acid emulsify the fat to increase surface area to let the pancreatic lipase get the lipid easier to digest. Then they enter the small intestines as chylomicrons and float around until they go to lacteals, to the lymphatic system, then the bloodstream, and then they get stored in adipose tissues until they are needed. But why do lipids go through a separate process than the proteins and carbohydrates? Why are they so special?
Because
Is it
they're hydrophobic.
Yes, they're hydrophobic and
they're denser and harder to break down?
yes, they're denser and hard to break down. They're huge. They're huge. They can't fit is the answer. They can't pass through um the villi, the microvilli, like the other two can. Okay, how is protein digested and absorbed? What kind of enzymes are used throughout the whole process?
Amylase,
Not amylase.
protease,
Amylase is the one for carbs. Protease, there's pepsin, gastrin, and stomach acid the in the stomach. And then in the small intestines, the chylocystokinin and trypsin. And then they enter through the microvilli that the that the lipids cannot, and they go in the absorptive cells lining small intestines. Then, since they're soluble in water, they could travel through, so there's no need for repackaging. And it's simply active absorption through the cells. They travel through the portal vein through the liver where they are stored and used and redistributed.
I thought enzymes always ended with a ASE or an ACE sound, like
So,
amylase or
oh,
lipase.
yes, that's true. The enzymes are activated by all these hormones. So if it ends with the IN, it's the hormone that activates the enzyme. So enzymes help slow the activation, like lower the activation energy for processes. But before you even get the enzymes out there, you need a hormone to trigger them. So all of these hormones activate some sort of enzyme.
Do we need to know which enzyme that is to
Most of
break
the
down
time,
proteins?
you just add the ACE to it. To like pepsin, I gotta remember what this is. They all do have one that they correlate to, so knowing that would be helpful for the midterm. Yeah. Do you have any more questions? Okay, moving on. What are the functions of insulin and glucagon?
Blood sugar regulation and long-term energy.
Can you be more specific?
Like
Like which one
insulin,
does what? Yeah.
insulin lowers your blood sugar level and glucagon's a long-term storage. So when you run out of glucose, you use glucagon, I think.
Glucagon, well, that one is glycogen. So glucose, these both are hormones. And you're right about how when we don't have enough blood sugar, so here's a fun graph that shows it. It's also like a partnership. It's like a yin yang effect. And they're both affected, like you talked about, by how much blood sugar we have in our blood. So if we don't have enough of it, glucagon is released, and which is down here, if you can see. Um, and when that is released, glycogen is the form of glucose that's stored in our bodies because it's more tightly packed. It starts breaking down into glucose. So you're right, it releases glucose into our blood sugar and it brings it back into homeostasis, back to its normal range. And gluconeogenesis, that is creating glucose from non-glucose materials, such as like proteins, lipids, and other things. So if you don't have enough glycogen in our body, it will start taking it from other things. And we could go more into that, but I want to finish the top part too. If you have a lot of blood glucose, insulin is released from the pancreas. They're both released by the pancreas. Insulin is released, and that turns the glucose into the blood rapidly into glycogen so we can store it, so we can use it and save it for later. So they're both activated at different times of our blood sugar, like what is needed to make it in homeostasis. Does anyone have any questions about this? Okay, moving on. It's pretty cool. Oh, also glucagon is called the fasting hormone. Um, like it's called the fasting hormone because it takes between like 4 to 6 hours for us to when we eat something for it to be like digested in our stomach and absorbed. So if you keep snacking and like activating the insulin, then you're always going to be releasing this fed state hormone. But if you don't eat for a period of time, our insulin's not going to be released, and then our blood sugar is going to go down. So glucagon is releasing glucose from our storages. Pretty cool how our body has these systems. Okay, what are the differences between type 1 and type 2 diabetes?
So, type 1 is, I believe, kind of what you're born with, or it's genetic, whereas type 2 is usually caused by lifestyle factors. And type 2 is your body, I believe, has too much insulin that it can't uptake it efficiently. And then I'm not sure what the system of type 1 entails.
Type 1 is an autoimmune attack on the pancreas specifically, while type 2, like you mentioned, is lifestyle. It is resistance. So our body is not producing enough insulin to match what we're consuming. And so there's a lot of factors that come into play. Like you said, type 1 is mostly genetics, but type 2 is heavily dependent on lifestyle. And they both have very similar symptoms. And the treatment is also similar, as well as the complications. But good thing, like modern medicine, like people can take insulin, even though it's expensive, unfortunately. But back then, having too much insulin, like sometimes when they were testing how much insulin someone needs to like match how much they consume, it could be like fatal because they were testing it. So thanks for modern medicine. Okay, carbohydrates. What are the differences between glucose and glycogen? Oh, we sort of covered this. I bet you guys could answer this. There's a lot of words that look like this, but I hope you guys can distinguish them now. Glycogen is a stored form of glucose. That is true. Glucose is the primary carbohydrate used in our body to make energy, and glycogen is the primary for carbohydrates stored in animals. Specifically animals, not in plants. Plants store their energy source differently. Um, Also, glucose is one of the most valuable energy source. Our brain prefers it the most. So when you are feeling like a brain slump or a brain fog or something where you just need more energy, eating some simple sugars could perk you right back up. So it's good to know. What is a lactose intolerance? What does this have to do with carbohydrates? You know?
Lactose intolerance is you don't produce the lactase enzyme to break down milk protein.
Yep. It's so unfortunate. I'm lactose intolerant and I really like cheese. It's sugar. I mean, the intolerance is that you don't make enough enzyme, like you mentioned, but this enzyme specifically breaks down lactose, which is a sugar, a carbohydrates. It moves to the large intestines, as we talked about how like carbs get broken down and absorbed in the small intestines. When it migrates to the large intestines, the bacteria is like consuming it and breaking it down, which causes a lot of gas and bloating, cramps, diarrhea. And this is not the same thing as a dairy allergy. Like we talked about earlier, dairy allergy is a protein and it's when our body overreacts to it. It's a immunity thing. And while this is just like not having enough of an enzyme. Why do we need to consume complex carbs instead of just glucose or other monosaccharides? This is the perfect time of year to ask that questions. All the kids at the preschool workout are like, why can't we just eat candy? What are you gonna tell them?
They're more long-term energy and I think they take longer to break down. So yeah, it's more long-term energy.
Yep, that is perfectly correct. You get steady energy throughout the day while eating something with less chains, less bonds that are like super fast for that goes to our brain. It'll just give us a quick spike and then we'll like crash out later. And the example I use is beans. They have high amylose content, which is not effective if you need a sugar spike. So if someone needs some sugar, you should not give them beans because that's not going to help them. But rice, short grain rice, they have high amylopectin, which means more sugar released into the bloodstream more quickly. What are the differences between sugar alcohols and artificial sweeteners?
Because one raises the blood sugar.
One raises the blood sugar, is that what you said?
Yes.
All I know is that the most important thing you should know is artificial sweeteners contain 0 calories, so they don't give you anything, any value to your body. They just go through your whole system. While sugar alcohols is 2.6 calories per gram, which is way less than typical table sugar, which is, do you guys remember how much energy carbohydrates give you? How many calories per gram? Pop quiz. Come on, you guys got this.
4.
Ding ding ding. 4. Okay, what about lipids? How many?
9.
Ding ding ding. And what about protein?
4.
What about alcohol? I don't think you covered this, but I'm curious if anyone knows because this one's a funny one and it makes a lot of sense. Alcohol is one of the most like in American diet for like male like adults, and it's
Is it?
because it's
Oh, sorry.
oh go for it, go for it.
Is it 9 as well?
No, it's not nine, it's seven. It's way more than protein and carbohydrates, which is why when people consume a lot of beer, they get that beer belly, you know? But pretty cool. Anyways, so sugar alcohols is way less than table sugar. So people seek it out for alternatives. What are the differences between soluble and insoluble fibers? My favorite topic.
One our bodies can absorb and use, and one our bodies cannot. And
Which is which?
soluble, you can use like soluble fiber. You can use because you digest it, and insoluble fiber, you do not digest, but it helps with can't think of the word, but you know what I'm talking about, hopefully.
Ding, ding, ding. You're absolutely correct. Soluble is the ones that you can digest, and it's called soluble because you could dissolve it in water. It specifically, their function is, well, nutritionally wise, they give you carbs and all that, but they also feed our gut microbiota, which is a topic being like super studied on by now. It is in your large intestines, and the more diverse soluble fibers you consume, the more diverse your gut microbiota is, which is super important if you want to be healthy. Because if there's a diverse gut microbiota, like they have found associations like that you won't get as sick or you'll have more like soldiers to fight for you in that way. And in this like Netflix documentary that came out that was studying the microbiota, they learned that sometimes like it's associated with like acne. So if you do like a fecal transplant to someone and you have acne, you might accidentally give them acne or even like mental health problems. So be careful where you get your fecal transplant from. And insoluble fiber, like you mentioned, we can't consume it. But it seems like a really bad thing, right? But our bodies don't have the enzymes to break it down. There's like a specific bond I learned, and our bodies just don't have the enzymes for it. So that's not a bad thing because it makes really good roughage for poop. So if you are having a hard time in the bathroom, eating insoluble fibers like celery is very like, rough, stringy, and it has a lot of cellulose. It makes good roughage. But eating fiber, a lot of fiber, even though it's good for you, if you don't consume enough water, it will make you constipated still, because water is what helps um with that. Does anyone have any questions about this topic? Okay, can you all put in the chat an example of a soluble fiber and an example of an insoluble fiber? You could just list examples. And let me tell you, none of you guys should be listing animal products. There's no fiber in animal products. Yep, apples. The rough skin of apples is insoluble. The soluble part is the inside of the apple. Chia seeds, yes, they're very soluble. Oats are soluble. Oranges, a lot of fruits that have like an outer shell or like a skin, that's usually insoluble. While the inside, where it's like moist and like dissolved, like very wet, like that's very soluble. Ooh, mangoes. Oh, you're making me hungry. Yeah, celery, avocados, carrots, chickpeas, broccoli. Yes, mango. Love mango. Prunes. Okay. Next, oh, dates. Dates are yummy too. Okay, other. What are the benefits of a plant-based diet?
You're consuming more vegetables, so more fiber.
Yes,
And it's
definitely more
And
fiber.
I guess less saturated fat as animal products.
Yep.
it's better for the environment.
Yes, that's a great one. There's also a lot of phytochemicals. Do you guys remember what phytochemicals are? It's basically anything else that isn't like a nutritional value. It adds benefits like antioxidants from blueberries and stuff like that. So the plant-based diets have a lot of phytochemicals and lots of reduced risk of health problems like cardiovascular disease, hypertension, diabetes, cancer, obesity. It increases your longevity. There's a lot more fiber like we talked about, magnesium, folate, vitamin E, calcium, and phytochemicals. Yep, they're nutrition rich and vitamin rich. What are the recommended daily allowance for proteins, lipids, and carbohydrates?
Protein, it's 0.8, is it 0.8 grams per kilogram of body weight?
Let's see. You are
Carbo
right.
ca-
Okay, you could say it. Pretend you didn't see it since you know it.
130 grams a day of carbohydrates.
Nice. And there's
I was gonna
no RD. Yep, it's zero point 0.8 grams of proteins per kilogram of body weight a day and 130 grams a day of carbohydrates. And there's no RDAs for lipids because, like we talk about, everyone, like it's not hard to get lipids in you. Lipids are tasty. People are typically consuming enough lipids. How much calories do lipids? Oh, we just talked about this. I bet you guys could write this in the chat. How many calories do lipids, carbohydrates, and proteins offer per gram?
4.
449. Yeah, lipids 9, carbs 4, proteins 4, and alcohol 7. Now you know something new. Is coconut oil long or short chain fatty acids?
Short chain.
That was a pop quiz that it was neither. They're medium. They're a mixture of both. So I guess you're part right. It's because they do have short and long, but they're medium. They're solid at room temperature and they're saturated. So that means there's not a lot of double bonds. Um, they absorb more easily than butter because it has more medium chains than butter. And it's better for people who are underweight. Like if you are in the hospital and you're losing a lot of weight, consuming coconut oil helps. And it's better for people who want to gain weight. Better for people with digestive problems because you can consume it better than with saturated fats. So this was just like a fun fact I learned that I thought you guys might find interesting. Okay, and the last question. How does a heart attack occur? I feel like a lot of these slides gave hints to this, but I bet you guys know it.
So your arteries get blocked with plaque, usually from too much lipids, I believe, and blood is not able to transport properly between the heart and the rest of the body, and oxygen, therefore.
Mic drop. Nice. Well said. Um, the most important part to know about this heart attack like scenario is there's always like if you have a lot of plaque in your arteries, you just have higher risk of developing a heart attack. But a clot will only form like get stuck, right? If there's a vessel damage. So you know like your blood vessels, if there's a damage to it and all the white blood cells move it, then the plaque cakes it. And then when the blood clots come, it can't go through. So if you don't have any vessel damage, but you have a lot of like plaque can't build up because there's nothing for it to cling on to. So yeah, cholesterol, yeah, it increases your risk of a vessel damage. So this is the order of how it works. Cardiovascular disease is one of the leading causes of American death. So knowing this is super important. And nutritionally wise, how to prevent it. Consuming a lot of high density lipoproteins, like we talked about, not low density lipoprotein, could help decrease the chances of this. As well as omega-6. Does anyone have any more questions? Because that is the end of our Jeopardy game. Thank you all for coming. I'll be here for the rest of the time if you guys have any questions, or if you want to go study for your midterms, you're welcome to. But remember to type your email in the chat so I could take attendance.
Thank you.
Of course.
Appreciate it.
Good luck.
You. This is like a random question. I don't know if it's like definitely in the assignment, I guess, but is our midterm like through Proctorio or like through Canvas itself or anything?
It's through Canvas itself.
Oh, okay.
Yeah. I'm glad.
Okay.
Those apps are kind of scary to me too. Like downloading a whole program, all the software, things could go wrong, but
Yeah.
you got this. I
Okay,
believe in
cool.
you.
Thank you. I just wanted to double check because I took one other online class and it was like all with Proctorio, and I've noticed that